Hi, this is Lori, and this is the second part in my three-part series of videos on Shut the Box game. In the second part here, we're going to code the game in Python. This is just a quick overview. So part one was the game rules and how to 3D print a game tray to play the game physically. And in this part, we're going to talk about the Python code to play it on our PC. And then in part three, we're going to take that Python code and put it into MicroPython so that we can play it on a Pico, a Raspberry Pi Pico. And I'm going to use a Pico Display Pack from Pimoroni to do that. So I have 4 buttons and a display all attached, and I plug the Pico into the back. Here's the code, and I just want to take a minute to say I'm not really demonstrating how I came about this. I've done that with previous videos in the Pico series, where I kind of show how I attack a problem like this, where I break up the task of programming this whole game into smaller subtasks and then do each subtask and then eventually stitch it all back together again. And so if you're kind of new to programming these things, don't think that somebody, well, at least don't think that I sat down and just started writing this and didn't have to like tackle it bit by bit. So you're seeing a version 2 even. Version 1 ran with a simplified version of the rules, and I worked on this quite a bit till I got it into this nice compact set of code. So it takes a while to put something like this together, especially if you're not an expert programmer in Python, as I am not an expert. All right, so version 2 allows the roll of a single die when there are 6 or less of the tiles. 6 or less are all that's up now at this point. So 7, 8, or 9 are gone. That's a better way to say it. We'll need the random library to get the random numbers for the dice roll. And I'll control this whole game in a loop, a while loop, and I'll use this variable game over. As long as it's false, the loop will keep running, and then whenever game over ends up equal true, that's the game will end. We'll have an array to contain the tiles that are available, and so as we play the game and we use tiles, they'll get removed from this list, and that way we'll know what's available. And then we need a variable to know whether we can just roll 1. And I do a fair amount of checking of the user input to make sure people pick tiles that actually sum up to their roll total and are tiles that are still available and are not numbers outside of 1 to 9. Now, the meat of this program is a function I wrote called roll check. And I think this was the hardest part of it for me, at least, was I needed a way for the program to decide whether there was a solution. So you roll the dice, and of the tiles that are still available, can you make that sum with the available numbers? And so how do you go about writing a piece of code that can check for that? And I started looking into that idea of looking at combinations and triplets and so forth to find a sum. And I found that that's probably done by a recursive algorithm approach when you're trying to do it in a very general way. And the recursive programming is a little bit challenging, I think. And I started to dig into that, and then I said, no, this situation is pretty simple, and it doesn't need a general approach. So I kind of have this brute force way of doing it. I just kind of go through all the possibilities to see if there's a solution. And so we'll start off with this function called roll check. It takes in whatever the total for the dice that you've rolled, and it takes in the array of the currently available numbers. Then whatever it is, say you roll a 7, but there's still an 8 or 9 available, well, that's not a solution, so we can eliminate anything greater than the roll total. So that's what this does. It just reduces the available nums to those that are the total or less. And then we need the length of that array for doing some of the looping that we'll do below. And the first thing we'll do is try to find the simplest solution. The simplest solution is for the total you have, that total is a tile available. And if that's the case, if we have that, we'll return true. Yes, there's a solution. If that's not possible, then we'll go to the next step. We'll look for pairs of numbers that will sum to the total. So we have a couple of for loops here that go through and see if any pair will equal the roll total. And if we find one, we'll immediately return true. If we get through the pairs and haven't found anything, we'll then go to triplets, sums of 3 numbers, to see if any of those will equal the roll total. And again, if there are, we'll return a true. And in terms of sets of 4 numbers, the max we can roll is a 12. And for any set of 4 numbers, the only set of 4 numbers that will be less than 12 is the sum of 1, 2, 3, 4, which is 10. So that's the only set of 4 that we can get that will work in any situation. So we'll just check for that one and return true if that's the case. And otherwise, if we've gotten through all these possibilities, then that means there's not a way to do it. There's not a solution. So we'll return false, and that'll end the game. So as I said, that was the thing that took me the most time to kind of come up with, and probably because I got a little lost in recursive algorithms, thinking that was something I had to understand before I could do this program. So I just did that brute force approach. Now for the gameplay, we'll have this while loop, and we'll set game over is set to false to start, so it'll run through this loop at least once, and it'll immediately check to see if we can roll 1 dice. If we can, we'll set that to true, and then that's what will tell the user that here's what is available. You can roll just 1 dice if you want to. And if you do want to, type yes, and if you don't, type no. And so if you type yes, then you will roll 1 die and you'll get the die total for just 1. Otherwise, you're going to roll 2 and you'll get the die total for 2. Well, you'll get the 2 numbers. And then you'll be told what are the available tiles. And then now we're going to check and see if we can even do a solution with that die total and what's still available at this point. And if we can't, then we're going to report that back to the user, tell them their score, and stop the game, set game over to true. Then the next place is where we check for user errors and also get the input from the player. What tiles do they want to pick? So this means there's a solution. So what tiles do they want to pick to use for this roll? And then we check and make sure that the tiles they pick are something they can choose. So we'll get their solution, and this is a list comprehension that will get those numbers and split it apart, turn them into numbers and so forth. So it's a nice kind of one-liner there. And then we're going to check and see, does the sum of their choices actually equal the die total? Did they do it right? If not, we'll tell them that didn't work and you need to try again. If it gets through that, we'll check, did they pick numbers they could pick? Or did they use tiles perhaps that were already used? Or did they pick a number and they should say 1 to 9 that wasn't a number that they could even choose? And if that's the case, then they get a chance to try again. And otherwise, we'll say, there's not an error. We'll set it to false, and we'll remove those tiles from the available tile list, and we'll go back around to the top. So I'm not the most efficient programmer, but it took 59 lines of code. Even there's a lot of comments in here, but 59 lines of code. I think that was pretty good. To get a basic version of this game going. Try this program out. So I'll kick it off. And you'll see immediately that we've rolled a 5 and a 5, so we have a total of 10. And it says, what tiles do I want to pull down? And you see I have all of them available, so I would do 1 and 9. Let's try that. And our next roll is a 5 and a 1 for a total of 6. And you can see 1 and 9 are no longer in the tiles available, so that worked correctly. So we have a 6, so let's try something wrong. Let's try to take down tile 7 and see if it'll let us do that. And you can see, yeah, 7 doesn't equal the die total of 6. So try again. So okay, that didn't work. So maybe instead we'll try to do a 6. So we'll put 6 in, and we moved forward. So now we have a total of 9, and we can get a 9 by a 7 and 2. We could also do a 4 and 5. I'll probably do the 2 and 7. I try to get the higher numbers as soon as I can. So let's do that. Okay, we rolled a 1 and a 1, so 2, and you can see that there was no way we could make a 2 with the tiles that are still available. So there's no play available for this roll, and the game was over. So our score was 20. That's not a particularly great score. And you notice we never got offered to just roll 1 because we had 8 available at the end, so we had to roll 2, and so yeah, that's kind of how the Python program works. I'm pretty pleased with that it's relatively simple, and I said the hardest thing was figuring out how to check to see if there was a play available, and now that we've got that tackled, as we try to, in the next episode, put it on our Pico and use our Pico Display Pack as our interface, we have at least the running of the program done. But the next challenge will be getting it on this teeny little display and making all the user input work with just some buttons. So the most of the code that we'll use in part 3 will be about working with this display and getting user input from the buttons, which was a fun challenge. So I hope you'll join me for part 3, and as always, I want to thank you for watching.